Hello everyone. Today we have a torque/equilibrium question. So this is physics. So here, let's say we have this structure right here, and you will have something that is suspended out of it, and you have this tension, a string that's pulling this on this side. Okay. So what's given is it's given the distance from here to here. Let's call this d1. Okay, I'm going to use variables, but you could use numbers if you want. And you go from here to here, and we're going to call this d2. That's what you're given. This here you're given also, which is theta. Okay, and also it tells you, so you got that. This is big M, this is small m. Okay, and that's it. So the question is asking about what force is the wall exerting on the beam. So imagine that this is the wall, and we're saying what force is the wall exerting on the beam. So first things first, we need to find the forces acting on that drawing right here. So first, acting on the beam. So here, acting on the beam, we have the weight. So this is big mg. Okay, in the middle here we have this right here, which is mg, smaller mg. Okay, here we've got this tension. So this tension is broken down into this y component. I'm gonna call it ty. This is t, and broken down to this x component. So this is Tx, okay? In addition to that, there is the wall force that's being exerted. So the wall here exerts this force right here. This is the force wall. So you both have the uh, x and the y component, the wy for that force wall. Okay, so first things first, we need to figure out the x's or the tension at one side in order to figure out the other. Okay, so first things first, we need to find the torque that is made up. So we know that the net torque, because it's not moving, or else it's going to move, is going to be equal to 0. Okay, around pivot point number 1. So we're going to use pivot point number 1 to be here. So that's my pivot point. Okay, going, so this is going to pull it this direction. Going this direction is going to be negative. Going the other direction is going to be positive. Okay, so counterclockwise is positive. You could do other way around, but you have to be consistent. So what's going to happen is that you're going to do torque. So we're just going to use torque. So going up, so it's going to be ty, okay, and then the distance from here until ty, which is d1. Okay, this is equal to, and then you have something else here. So you've got your two forces acting downward, and this one and this one. So we're going to subtract mg multiplied by d2 on 2. So it's half of d2. And then you've got your minus big mg, that is multiplied by d2. Okay, and all of this is going to equal to 0. Okay, so what we're trying to find here is that we're trying to find ty. Okay, so we have ty, but we need actually to find the tension, because when I find the tension, then that could help me figure out the other parts. Okay, so I need to figure out the tension from this right here. So let's figure this out. So if we measured this theta, if I moved around using the 0, so it's going this right here, so this is going to be theta, so that is theta. So I could do that t, my tension, is equal to the sine of theta. Okay, so that's your opposite over your adjacent. Okay, so that's your sine theta multiplied by d1, which is going to equal, so I'm going to move these over to the other side, equal to, and I'm going to take a g out, or never mind, we could use mg d2 on 2 plus mg d2. Okay, and then I'm going to divide by d1 and then divide by sine of theta. So I know that my t is going to equal to mg d2 on 2 plus mg d2 all over sine theta d2 d1. Okay, so here I figure out the tension, which is right here. So that's your tension. This is tension right here is equal to that. Okay, so after this, after I figure out the tension, we could use the forces acting on the x and y direction to figure out the rest of this. So we could do this. We could say that the forces acting on the y direction is going to equal to 0. Okay, so we know that you have all the forces. So that is Fwy, which is the one right here, Fwy, plus, so going up is going to be positive, going down is going to be negative, it's going to be Ty, which is going to equal to this and this right here. Okay, so it's going to be equal to your mg, big mg plus little mg that are going down. Okay, so after that, here I know that all of this sine theta is going to give me my it's going to give me my my ty. Okay, so this is going to equal to Fwy, okay, plus my t sine theta. Okay, that is going to equal to mg plus mg. Can move this around, so Fwy is going to equal to mg plus mg minus t sine theta. Okay, now I know that t is equal to this, so I can bring this down right here. So for, if there were numbers, it would be much easier to figure this out. Okay, the second thing that I could do is I could find all the forces acting on the x direction, which are equal to 0. So I could say only two forces that are acting on the x direction are this force, and this one, the tx and the fwx. Now the tx is technically equal to the fwx. Okay, so these two are equal. So we know that this is going to be fwx. The wall is equal to tx. Okay, so we know that this is going to be twx. It's going to equal to t cosine of theta. Okay, now if we know, again, these are numbers, you could just plug in this right here. But the key idea here is to figure out your tension first, because it will then help you figure out your Tx and your Ty, and then you could figure out the forces on the wall from the x and the y direction. So after you figured out those, you would create a triangle. So here you've got your Fw. We know that this is going to be Fw right here, and this is going to be Fwx, y. Okay, and after that, I know that if I did this right here, okay, and you could use your triangle rules, and you're going to figure out that this is theta that we could find for the angle. Okay, but we don't need this for this question, so we just need to figure out dw, or all you need to do is you just have to Fwy squared plus Fwx squared is going to equal to Fw squared. A squared plus b squared equal to c squared, and then you take the square root of this, and that is your answer to figure out your Fw. Okay, thank you so much. Hope this helps, and have a good day.